everybody to Tech Talk episode number 16. Stop looking at me, QAM. Or should I do it in the voice? Stop looking at me, QAM.
Stop looking at me, QAM.
Oh. So, yes, stop looking at me, QAM. Which is spelled QAM. There is no U in QAM. And you're probably thinking, what is this word that they keep talking about? And we'll get to that in just a moment. But today we do have some fun stuff we're going to chat about. I'm Ryan Bowman. That's Brian East with Connect Us. And we're going to be chatting about some LTE technology, because often we get asked about some of the different variables on why a Cat 18 device might be faster than a Category 4 or a Category 6. And earlier in our Tech Talks, we talked about carrier aggregation, which is really, really important. Carrier aggregation allows multiple data streams. So when you think about how that can multiply, right? If Brian is the end device router and I'm the tower, well, prior to Category 6 LTE, there was no carrier aggregation. So we could only transfer information back in one stream. And then Category 6 got launched, and that added carrier aggregation. And Category 7 actually added some for the upload side. And now you can have up to 2 or 3 streams of data going back and forth between them. So that's huge. That's one factor of what we're talking about.
A new thing with 5G is working on 4 streams.
Yeah, right. So yeah, and it's always improving, right? That's a great point, because everything we're going to talk about today continues to get built upon and increases bandwidth and speeds and efficiency and all that good stuff, right? We're always driving towards more efficiency and more. So today, like I had mentioned, we're going to stop looking at me, QAM. QAM actually stands for Quadrature Amplitude Modulation, which is crazy. And let me share my screen here, because we'll talk a little bit about the background. I'm not going to go crazy. I'm just excited I get to say these really big words that I don't understand, and that's just pretty awesome.
It makes people think we're smart.
It does, yeah. It's super cool.
Suckers.
So let's jump into this, right? OFDMA. The first time I heard that acronym was like in 2010, 2011. I was with Verizon. We were launching LTE, and this really other smart person I knew was like, oh yeah, OFDMA, orthogonal frequency divisionable multiple access. I was like, what? Orthodontics? Ortho what?
Orthodontist?
And so
what does it have to do with teeth?
Yeah, right. So anyhow,
brace for the real story.
Yeah, we're not going to get hung up on orthogonal frequency divisionable multiple access, right? What we're going to say is that is part of a communication technology that was introduced in the LTE networks when LTE launched, 10, 15 years ago, right? We're also seeing OFDMA play a role in Wi-Fi 6, which is pretty cool as well, right? So all these neat different technologies. But what OFDMA did, by carriers being able to leverage that technology, they also started to be able to leverage QAM, which again was that quadrature amplitude modulation, right? So just in case. So here's what QAM is, right? So quadrature.
Pictionary.
What's that?
Imagine trying to do charades or Pictionary with QAM.
Yes, yeah, that would be.
How do you pull that off?
Well,
in the comments.
Let's talk a little bit about it, actually, because one of my buddies, and a shout out to Aaron, my one buddy, he uses it as his explanation of it is ears and mouth, right? So now start thinking of your device as a device that has sets of ears and mouths, right? So we already talked about carrier aggregation, right? Now we talked about multiple streams, but now think about this. If you have a device, the more ears and mouths that device has, the more communication it can process. It can hear more of that data coming in, and it can speak more of the data going out, right? So now when you start thinking of it like that, when you start thinking of this device, this is just yet another efficiency, because everyone wants like one simple, this is why my Cat 18 device is faster. But the realization here is the facts are there's a multitude of things that are helping that Cat 18 device be a whole lot faster than a Cat 6. or a Cat 10 or 12 or whatever, right? And so carrier aggregation was one, QAM is another, ears and mouths. So if you can, you can see this. I pulled this a little bit of data here from the internet as far as the different QAMs that are out there, and each one of them with each category through the 3GPP, right, release of LTE categories brought us additional advantages and additional technologies to be able to leverage that, right? So when we look at this is just kind of a really good example on the left-hand side, right? When we're looking at the left-hand side here, you can see the level of QAM, and that bits symbol, bits hertz. Think of that as the sets of ears and mouths, right? So that's kind of, and then of course on the far right, you can see the actual gain in capacity, right? So again, this is what happens when you have a Cat 18 device now. You're seeing that efficiency because of the QAM rating, right? So a Cat 18 device is using 256 QAM. That means it's got 8 sets of ears and mouths that it's processing that data. Versus, let's use a Cat 4, for example, is using a 16-bit QAM, right? So it's 4 sets of ears and mouths. So the difference in being able to leverage that, and then you add that with carrier aggregation, you've got 4 sets of ears and mouths talking through 1, or 4 sets talking through 2, or 4 sets talking through 3, right? You get all this multiplication happening, and all of a sudden you can really see the difference in speeds that are happening, and that's both on the download and the upload. So on the right hand side, I have
exponential, right? These are all binary, exponents of 2, right?
Yeah.
Just like any logic gate.
Yep. Yeah, absolutely. And so on the right there, you can see, if you look at 16 versus 64 QAM, just in that, what your difference is going to be, and then add carrier aggregation in there, and just like Brian said, all of a sudden you're multiplying that even further out, and that bigger gap gets multiplied and becomes an even greater gap of why one does a little less than the other. So again, I didn't want to go crazy with the actual definitions and all of that. We could have spent a little time sitting on those, but really it's just another component to when we're talking about the different LTE categories, and when we're talking about why this router is outperforming this router. Just look at some of the differences, because one of the things we get asked a lot, why the cost difference, right? Why does a Cat 18 or a Cat 20 router cost so much more than a Cat 6, right? And here are some of the reasons, right? There's a lot of reasons that factor into it, but a lot of them are efficiency. A lot of them are just leveraging more technology, and that there's an understanding there that as that is built out and as those products cost more to bring to market, there's a higher cost for those products. I mean, that's just as simple as that, right? So I want everyone to understand that when we're talking about, an application where a customer might need to stream data, or they have VoIP calls, or they have simultaneous VoIP calls in an office, or whatever that looks like, there is reasons why we're recommending certain higher category routers to accomplish this. And it's not always just, hey, I need this much bandwidth. There's other factors that are falling into that as far as how fast that bandwidth can travel, how efficient the router can be, and resourceful, right? So and being able to leverage those resources. No different than, you have to take into consideration processing speeds. Those are all different factors that are going to play into this. If you've ever done a speed test using a computer, go out and find yourself a Toshiba satellite from 1998, and then go get yourself a MacBook, Pro with an M2 chip in it, and go to speed test on the same internet service, and you'll see a dramatic difference in your speed test results. It had nothing to do with the internet service that you're on. It has everything to do with the processing power of that piece of hardware. And so, you have to understand there's so many factors that come into play as we're recommending different routers and different solutions for you. So that is our QAM today. Yeah, I was going to say, does that make sense, Brian?
Huh?
Yeah.
What were
we're
we
talking about frequency or orthodontics,
Absolutely.
Like
Does. You know,
binators and
it's,
retainers.
you know, the main takeaways on this is, you know, we're not necessarily wanting the carrier rep or the viewer to be able to calculate the you know, percent gain based off of, you know, these exponential values and going from there, but to get the overall idea. And we found, Ryan and I have found that teaching a little bit more in depth of what we want you to capture is essential, right? So it's along the lines of Goethe's famous quote, right? A man who's ignorant of another language is ignorant of his own. If you know another side of it, if you know a little bit more than what it is that you actually need to know, it puts that into perspective for you. So it's the overall takeaway that really matters. And the takeaways from this should be that QAM, in addition to carrier aggregation, are, you know, are the main differences in speed. And like Feitner said, Ryan's friend, you know, it's the number of sets of ears and mouths. And you're going to put more ears and mouths into a device, and then you're going to put the infrastructure into the device, the hardware in the device that'll be able to handle all of that. Price is going to go up.
Yep.
But
yeah.
Productivity will as well.
I was gonna say, and so will performance, right? That's perfect. Yeah. So that's what we got for you this week on Tech Talk. We have no technical thing, no toy to play with this week, but we got toys coming. We got a lot of fun stuff coming down the road here, and it's gonna be pretty darn awesome. So continue as this even changes our Tech Talk. We're gonna be making some changes in the next month or so here, and adding some different components to it. It's going to be pretty darn awesome. Keep checking us out on LinkedIn, YouTube, and all those resources that we have out there from a connective standpoint. Feel free to reach out and ask us anything you need from our standpoint of, you know, cellular connectivity, routers, networking, all that good stuff. We are happy to help. So until next time, have an amazing day.
Stay metal.
Awesome. See you guys.